akan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh dan salam sejahtera. Okay, apa khabar? Hi everyone. Sorry, hi teachers, parents, and all wonderful students. Sorry, there are a very big technical problem this evening, so we are start quite late, but it is okay. We will try our best to present you whatever we're supposed to present. So I wish all of you welcome to Pusat Tuisyen Academy YouTuber, a joint venture with IDD Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma, selamanya percuma. Before we proceed, let's begin our session with the recitation of Umul Kitab Al-Fatihah for the Muslim and a moment of silence for the non-Muslim. Al-Fatiha. So how is everyone doing today? My prayer that everyone is in the best of health and ready for our class today. Before we start, let me introduce myself first. My name is Nun binti Muhammad Nur. You can call me Madam Nun. I am lecturer from College Matrikulasi Negeri Sembilan. I am your moderator and host controller for today's class. So the most important person today is our passionate and fantastic presenter, Madam Rosmaya. She is a very experienced teacher from SMJK Yuhua, Kajang Selangor. So let us give a warm welcome to Madam Rosmaya. Okay, so for the record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for the hard work in preparing today's lesson, please subscribe her channel as usual. The lesson will be approximately 1 hour. So the credit claim link will be given at the end of this session. For the credit claim, you need to collect the 1 letter and 5 digit codes which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. I would also like to remind students, if you wish to post any comment in the chat box, please use appropriate language and use appropriate profile picture. I am pretty sure all students here are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this class a lively one. Stay focused, and if you have any question, please write on the chat box and we will try to provide you with the answers. Before I give to Madam Rosmaya to present, I will announce the first digit code of the first letter and 2 digit code for the credit claim. So the first letter and 2 digit code is A37. Okay? A37. So without further ado, please welcome Madam Rosmaya to start our presentation. Okay, Madam Rosmaya.
Okay, Bismillahirrahmanirrahim. Assalamualaikum. Good evening. Hi everyone. Thank you to the moderator, Teacher Nun. Okay, also one of the very experienced lecturer at matriculation, especially College Matrikulasi Negeri Sembilan. Okay, I hope you all will stay focused, and if you have any question, you can write in the chat box. Okay, so now I'm going to open my slide. Okay, already open. So let me introduce the academy YouTuber team. Okay, so here is our team. Okay, me as a leader, and we have teacher Nun with us. Okay, and teachers, the other 2 teachers, teacher Su and teacher Hapsayu. Okay, next is in the academy YouTuber, we also have mathematics team lead by teacher Im, and biology team lead by Cikgu Faiza, and chemistry team lead by Cikgu Shahnon. Okay, perkhidmatan and economy team lead by Madam Fizi. Okay, so Academy YouTuber also has apps where you can download it from Google Play Store. And there are a lot of videos there, including the physics video. Okay, so now we've come to the main objective for today. Okay, our tuition's live class. We are going to do early revision on semester 1, chapter 3 and chapter 4. So chapter 3 topic is dynamics, and chapter 4 topics is work, energy and power. Okay, so I have posted the link to the PDF question in the description part below this YouTube channel. Okay, there are all 12 questions altogether, and congratulations to those who has tried the questions. You can check your answer and make correction if got any. Okay. And those who haven't done the link question PDF also, I've put in the chat box. You can also get the question PDF in the at the chat box. Okay, so this is the first question. Okay, let us read the question. An electric toy car which moves with constant velocity v is powered by an electric motor that provides a constant force. So the energy is supplied by the motor varies with time t according to the graph below. Okay, so we have given v, okay, is constant velocity, okay, powered by electric motor. So this is the P, we use symbol P for power. And then we have constant force F. So the energy, okay, time t, but from the graph E versus t, so the graph. Okay, so the relationship between F and V and P is given by P equals to FV. So we are going to use to derive the correct expression for the force, okay, for the force. Okay, so remember in secondary school you've learned, okay, P equals to E per T, the famous question, PET, okay, P equals to E per T, and from the work energy theorem, okay, energy work is changed in energy, so actually this one can use work. Okay, so work is force time distance, so you can see that how P now can be related to F. Okay, now S per T is V. Okay, so from the relationship, displacement equals to VT. Okay, so you can substitute into here. And P is E per T, okay, just now. And you cross, okay, now we substitute the point here, E, T, okay, into the equation. So we get gradient, gradient. E into E here, energy and time. Given here as capital letter T, so we follow the whatever given in the question. So given T capital letter here, and we cross multiply. Okay, another one to check here, E per T is constant, so we get F and V. F also constant, V constant, so they are equals. So FV is equals to E per T. So we cross multiply, we get F equals to E per TV. So now we get the answer. The answer is D. Okay, those who got the answer can also write in the chat box, so that our class will become more lively. Okay, I can see, we both of us can see your answer there. Maybe we can give a clap to them, right, if got correct answer. Okay, so those who have done, so write there in the chat box. Okay, so the answer is D. Congratulations those who got correct. Okay, now we go to second question. Okay, second question. Two blocks of equal mass are connected by an elastic string and pulled across a rough horizontal surface with uniform velocity by a force T. Okay, so force T as shown in the figure below. So equal mass, so let us use one symbol only for equal mass, M. Okay, uniform velocity, it is understood that if I mention uniform velocity, so that means acceleration is zero. So the pulling force is this T, so that means direction of motion supposed to be on the right side, right side. But the acceleration is zero. Okay, because uniform velocity, so direction of motion to the right. Okay, so this is the force T given. So because of a rough horizontal surface, so there is a frictional force. So for block, the first, this block, okay, the block, there are two blocks here. So their friction will be the same because same blocks and so same surface. So we just label it with F. And then we have also the tension in the string, okay, given by T1. So the tension in the string, so we just write here, this is action reaction force, okay, because of first block here and from the second block. So here is the T1, okay, action reaction force on the same string. Okay, so now we use Newton's law. From Newton's law, second law, F equals to ma. Okay, we separate the diagram, okay, and see what is the resultant force by the block. Okay, let's say this block. Okay, so we have T1 and F follow the direction of A as positive. So that's mean T1 minus F. Okay, because opposite direction. So T1 minus F equals to 0 because acceleration 0. So we get T1 equals to F. This show that equation A is correct. Okay, the questions one not correct. Okay, not correct. So A is correct. So let's continue with the second block. Okay, second block, the forces act on the block are T, okay, T1 and F. So now we use F equals to MA. So follow the A direction as motion direction as a positive. So T is positive and then F is minus and T1, okay, minus T1. Okay, so now we get the equation D is correct. We arrange here. T minus T1 bring F to the right side become plus F. So D is correct. So let's continue. Remaining, we have B and C. Which one is correct now? So we can substitute T1 equals to F into here. So we get T minus F minus F. So we get T equals to 2F. So that's mean B is also correct. So that's mean the answer is C. Not correct. The equation not correct is C. Okay, so that's our answer. So be careful with the question. Read carefully because the questions one's not correct. Okay, what about your answer? Do you have the same answer as given here? Okay, those who got correct answer, congratulations. Okay, I give you a clap, even though you don't write there in the chat box. Okay. Okay, now we go to question 3. Okay. Question 3. I hope my explanation is not too fast. Okay, you can catch up with whatever I explain. Okay, now we go to question 3. Okay, we read the question. Okay, two masses of 2 kilogram and 5 kilogram have the same kinetic energy. Okay, what is the ratio of the momentum of the 2 kilogram mass to the momentum of the 5 kilogram mass? Okay, so 2 kilogram we put as M1, 5 kilogram we put as M2. So they have same kinetic energy. So K1 equals to K2. So we use K to represent kinetic energy. And we're going to find the ratio of the momentum 2 kilogram first. So that's mean P we put as P1 per P2. P to represent momentum. Okay, so we use this relation K1 equals to K2 and formula for K kinetic energy is half mv squared. So we substitute half m1 v1 squared equals to half m2 v2 squared. So we can cancel half. Okay, now we get m1 v1 squared. We separate it too because we are going to relate with momentum. Okay, so m v1 v1 here, m2 v2 v2 because momentum is equals to mv. Okay, so now we separate the momentum. So we bring m2 v2 to the left side, so becomes momentum p1 per p2. That's what the questions wants, right? So P1 per P2 equals to V2 per V1. Okay, so now the V2 is not given, the V is not given. So if V not given, so we need to relate with, next is we are going to relate with M. We relate with M. So we use the same relationship given, K1 equals to K2. So we cancel half. Okay, now M1 V1 squared equals to M2 V2 squared. We bring M1 per M2 together and we put on the right side V2 squared per V1 squared. Okay, so now we have M here and we substitute the mass, the masses 2 and 5. Okay. Okay, then this one is square root, right? So we get this one is square. So that means V2 per V1 is equals to square root of 2 per 5. Okay, so now we can substitute into the top equation just now. Okay, so we get the ratio P1 to P2. So what's the answer? The answer is C. Okay, the answer is C. Okay, so hopefully you get the correct answer. Okay, so if you got any problems, you can just write there in the chat box. If you want, if got correction, you make your own correction there with your what you have done as your exercise. Before I give this earlier one day actually, the exercise. Okay, yesterday. Okay, so now we continue with question 4. Okay, question 4. A body moves in a straight line from rest on a smooth horizontal surface when a constant force acts on it. Okay, so which graph shows the variation of work done? Work with time t for the motion. Okay, so from rest here, it means that starting velocity is 0, or initial velocity. Okay, so u equals to 0. And the constant force, let's say F. Okay, now the variation of work T. The graph given all is work against T. So what is the variation? Is it a horizontal line or curved line like this, or a straight line, decreasing line like this? Okay, so let's see. Imagine here the body move with F, constant F, and it move with uh, from rest to a certain position here. So that's mean the distance of the distance it goes is S. Okay, so work to relate work with F, so we can use work is to equals to Fs. Okay, because F and S is already parallel to each other in the same direction. Okay, so now because there is no T here, okay, so we can use a linear equation. Okay, which one to use? What was Sutat? Okay, or V equals U plus AT, V squared equals to U squared plus 2AS, and S equals to UT plus half AT squared. So we choose which one? V is not given. V is not given, so that's mean we choose the S equals to UT plus half AT squared. Okay, so you substitute into here. So you get UT plus half AT squared, and the U is 0. So now the equation simplified to half FAT squared. So A, constant force, so that's mean constant acceleration. So the variation is between work and T. Work and T. Okay, so F and A are constant. So how it's their relationship. So from the T squared here, so that's mean it's a quadratic function here. This is a quadratic function because T squared. So that's mean the graph is a curve and it's positive. So the coefficient of T squared is positive. So that's mean the curve is a parabolic curve. The answer is D. Okay, parabolic curve. This is if coefficient is negative, coefficient of T squared. Okay, so the curve is like this. So this is quadratic function with positive coefficient of the T squared. So the graph is a curve graph. Okay, so what about your answer? Do you get the same answer as given here? Nobody right there. So looks like I talk alone here. Uh, okay, now we go to question 5. Okay, question 5. Okay, there, question 5. Okay, we read the question. Okay, most of the question given here to discuss is from STPM, actual question. Most of the question given here, actual question. Okay, so question 5. A pendulum bob which is attached to a string of length L is released at a position making an angle theta with respect to the vertical. So what is the speed of the bob when it is at the lowest position? So diagram not given, so you must be able to imagine. So this is a pendulum bob, length L and angle theta. and then we are going to find the speed at the lowest position. So it's the V final, or we can just write as V. Okay, so this is the pendulum bob. The length of the string is L and the angle from vertical is theta. So initial here is U equals to 0, initial velocity U equals to 0 before the bob is released, and the lowest position will be V. Okay, that is what we are going to find. Okay, this V. Okay, so the concept we use is the principle of conservation of energy. Okay, this one is in chapter 4. Principle of conservation of energy. So total of initial energy, kinetic energy plus potential energy equals to the final energy, kinetic plus potential energy. Okay, so you can rearrange the equation here. So you get Ui minus Uf equals to Kf minus Ki. So what is this? This is change in energy. So the left side will be loss in potential energy. So how it changed? So it lost in energy. So potential energy loss, and kinetic energy it is gain. Okay, so Kf minus Ki. So it's logic. If we think logic, when the object move, the bob here is released, so the velocity increasing. So the maximum velocity is here. So the kinetic energy increase. Increase. So that's why it's gain in kinetic energy. So we use this relationship. So we use the formula potential energy mgh and kinetic energy half mv squared. Okay, so now the h here is the height from lower position here to the top here. Okay, before the bob is released. So this is h, vertical height. Another word is vertical height. Okay, so the loss in potential energy will be mgh minus 0. Okay, so U initial is mgh and U final will be 0. Okay, what about the kf? Kf will be half mv squared and k initial will be 0 because U is 0. Okay, so now we get mgh equals to half mv squared. Okay, so we cancel m and we get speed, okay, equals to square root of 2gh. Okay, so now we substitute 2 and g, and now the problem is h because h is not given in the question. So we use trigonometric ratio. So catua here. Okay, so we choose here the what you call this, the right angle triangle to use Sochatua. So this is the right angle triangle colored with yellow, the triangle here. So the length here will be L minus H because this is the same string, right? String. So top to bottom here is L and the minus the H. So you get this side of the right angle triangle, and we can use cosine. Okay, cosine theta is adjacent. Adjacent is L minus H per hypotenuse L. Okay, so we cross multiply and bring L cos theta to the right side, becomes L minus L cos theta. Okay, and factor out L bracket, we get L minus cos theta. So now we can see the answer, which is the answer. The answer is D. Okay, similar to D. Okay, so that's the answer. Okay, now we go to question 6. Question 6. Okay, past year's question also, Stpm. Okay, we read the question. An ant of mass 1.2 gram climbs up a mirror 25 degrees from the vertical at a speed of 2.3 centimeter per second as shown in the diagram below. So what is the output power of the ant? Okay, so we want power. Given mass 1.2 gram, angle 25 degrees theta, and the speed 2.3 centimeter per second. Okay, so we are going to find power. Okay, so we are going to read, because this is power. So power is energy per time or work per time, because work energy theorem, work is change in energy. So we can use work over time. And W is change in potential energy. So you can use UF minus UI, the potential energy. Okay. So the N climbs up the mirror. So we use potential energy. So that's mean MGHF minus MGHI. Okay, F for final, I for initial. Mg is constant. The difference, the changing is in H. Okay, the height here, H. Initial height here is 0, so that's mean MGHF. So you substitute into here. So the H per T, okay, is V. Okay, so this is the vertical V because H is vertical. So we use vertical V. And okay, H per T, remember the displacement equals to velocity times time. So velocity is displacement per time. So in this case, is H per T. Okay, so the V, we use the vertical V. So we resolve the component of V. Okay, so the component of V is V cos 25 degrees and V sin 25 degrees. Okay, we take V cos 25 degrees into the equation, substitute into the equation here. Okay, angle 25 degrees. Okay, so now we get 2.7 times 10 to the power of negative 4 watt. So the answer is D. Okay, so the answer is D. Okay, next. Question 7. Okay. So Cikgu Non, Teacher Non, so are we going to stop or continue?
Okay, we can take a break because we have run our class almost 26 minutes. So let's take
Okay.
a break for a few minutes, students. We'll watch the advertisement. Okay.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, so welcome back everyone. So before we continue our class, I will announce the third digit code for the credit claim. So please listen carefully. The third digit code is number 3. Okay, the third digit code is number 3. Okay, so Madam Rosmaya, you can continue.
Okay, so what is our question just now?
Question number 6.
Question 7 6 done the end just now. Okay, so I open my slide. Okay, so going to continue with question 7. Okay, we read the question. A block with a mass of 0.20 kilogram is hung at the end of a spring and it is lifted vertically so that the spring is unstretched. So the block is then released and it touches the table with a velocity of 0.80 meter per second. So if the distance of the table from the release point of the spring is 0.10 meter, so what is the force constant of the spring? So we are given mass in the question, the mass of the block and the velocity V, okay, and the H distance is 0.10 meter, okay, from the table. Okay, so we are going to find the K constant. Okay, so next, how to imagine it? So this is the spring, okay. So the spring is lifted vertically so that the spring is unstretched, unstretched. So the initial U is 0. Okay. Next, when you release it, so it lower down, okay, lower down. So the velocity is given when it touch the table, okay, is 0.80 meter per second, okay, when it touch the table. So the height from the table to the where it is released from is 0.10 meter. Okay, so this is how you imagine. Okay, imagine picture is not given, a diagram is not given. So this is how you imagine the situation. Okay, so we are going to find K, constant, force constant of the spring. So we still use principle of conservation of energy. Okay, so total of initial energy, which is consists of kinetic energy and potential energy, equals to the final kinetic energy plus final potential energy. Okay, so potential energy we use formula mgh, and kinetic energy we use formula half mv squared. Okay, so initial energy is zero because U is zero, right? This is potential energy. So H starting point is we consider as zero. Sorry, this is kinetic energy. Kinetic energy is zero. Okay, correct. Just now what I say, U is zero. And then potential energy is mgh, initial, because it start from here before it is released. So we use mgh. H is 0.10 meter here. Okay, then the block will be on the table. On the table here, just touch the table. Release and touch the table. So it's half mv squared. Okay, plus V is what we are going to find. Oh no, V is given here, 0.80 meter per second. And half potential energy, we use half kx squared. Okay, half kx squared, energy of a spring. Okay, so we substitute the values. Okay, mass of the block 0.20, 9.81 is G value, and H is 0.10. And then half mv, okay, speed is given 0.80 square, and plus potential energy of the spring, we can use half kx squared. So half k x distance here, we can use h, 0.10 meter. Okay, so we just solve this. Okay, and we got k 26 newton per kilogram. Okay, so the answer means that the answer is B. Okay, so that's the answer. Okay, now we go to question 8. Okay, question 8. Okay, we read the question. A car moves with which graph shows the variation of power. Okay, so we use power equals to work over time. So work relationship from the work energy theorem. So work is change in kinetic energy. So U is 0. So that's mean the change in kinetic energy given by half mv squared. Okay, so you can substitute half mv squared into the equation here. So V is V times V, and why we do this? Because we are going to relate with acceleration. Here is acceleration. So half m v per t is acceleration because u is 0. So a v minus u per t will give you acceleration. And this is in the form of y equals to mx plus c. Is a linear graph. P varies with v. And half m also A is a constant value. So it means that P is directly proportional to V. So the graph is C. So it's a linear graph. Okay. Then we go to question 9. Okay, question 9. A block of mass 65 kilogram is placed at 8 centimeter above the top end of a long spring, which is fixed on the floor as shown in the diagram below. So this is a past year question also, Stpm question. Okay, so you are given M 65 grams. So H mentioned in the diagram here, 8 centimeter. And and K also given 66 Newton per meter. Okay, so A, we are going to find the energy transformation, state the energy transformation. So the energy transformation is starting point at the top here is gravitational potential energy. Then on the way, it fall down, so it changed to kinetic energy. And then when it hit the spring, so it changed to elastic potential energy. Comes from the spring. Okay, energy in the spring, so elastic potential energy. So this is the transformation of energy for the system. Okay, next B, determine the maximum compression of the spring. So maximum compression of the spring, so that's mean let's say we use X to represent the compression. So maximum compression X. So imagine the block hit the spring and it compress to a distance X. Okay, so we use principle of conservation of energy where total of energy is always constant. So at the top here is the maximum energy by potential gravitational potential energy, which is general formula is mgh. So the h here measured from top to the where the spring is maximum compressed. So h plus x which mean 8 plus x. So this is the from the initial energy and it's always constant the total energy on the way until it maximum compress here. So we use the elastic potential maximum for the spring, which is half kx squared. So x is the maximum compression. So now we use this relationship and we substitute all the values. M is 65 gram, convert to kilogram. G is 9.81 and H 8 centimeter, convert to meter plus X. Then half K is 66 Newton per meter and the X squared. So leaving here only one unknown that we are going to find X. X is what we are going to find, maximum compression. Okay, so we rearrange the equation here and we get x 0.050 meter. Okay, so this is a quadratic function, two values. So you choose the correct one, the possible one. Okay, you neglect the impossible answer. Okay, so the answer is x equals to 0.050 meter. Okay, so that's the answer for question B. Now we go to question 10. Okay, so this is the diagram, shows a body of mass 5 kilogram placed 1 meter high on an inclined plane with base 3 meter. The body slides down the inclined plane without friction. So calculate the velocity of the body when it reaches the bottom. Okay, so M given 1 meter and 3 meter given in the diagram here, the position of the distance and the length. So we are going to find the velocity when the body reach the bottom. Okay, reach the bottom. Okay, so question A first. Without friction, it is understood that there is no frictional force. Okay, so we use the principle of conservation of energy. Total of initial energy equals to total of final energy. And if we bring this K put together, so we get Ki minus Kf and Uf minus Ui. This means gain in kinetic energy is equals to loss in potential energy. So if we think the logic, when the block here going down, so at the end here will be kinetic energy increases. So that's mean gain in kinetic energy. So the potential energy will be lost because it going down to the bottom where we measured the height is from the bottom here. So loss in potential energy. Okay, so you substitute half mv squared equals to mgh. So we rearrange the equation. So we get V, because V is what we are going to find. So V equals to square root of 2GH. And we need to use H, 1 meter. Cannot use 3 because this is H, vertical height. So 1 meter. So be careful with distance you substitute into the equation. Okay, so the answer is 4.43 meter per second. Okay, so we take 3 significant figures here. Actually, 2 significant figures because given here all is 2 significant figures. So you round it off to 2 significant figures. I didn't do here. Okay, so this is question A answer without friction. Okay, now question B. Question B, so we put V into here. So we do B question. So if the body slides down the inclined plane with coefficient of friction equals to 0.2. Okay, so this time got friction. Okay, got friction. So what is the work done against the friction? So the work done against the friction, so we use formula work equals to Fs, and let's say the block S sliding down. So we resolve the component, determine all the forces that act on the block here. So we have force, weight, okay, mg. We have friction, which is equals to mu r, and we have reaction force, okay, by the inclined plane here. Okay, so work done against friction is F times S. So F dot S. So that's mean we must use F parallel to the S motion. The meaning of dot. So this F is a friction because the question asks work done against friction. So this F is F by friction. So friction is mu R. So mu R is equals to mg cos theta because R is upward direction and the component of mg is mg cos theta. Okay, one of the component, and R equals to mg cos theta because the block or the body doesn't fly, doesn't fly away. Okay, it remain sliding down the inclined plane. So that's why R is equals to mg cos theta. So the force upward equals to the force downward. R equals to mg cos theta. I repeat again, the object here, the body here doesn't fly and the inclined plane also doesn't collapse. So it remain on the inclined plane from top to the bottom. So we substitute here into the equation here, mu mg cos theta. Okay, now the distance must use distance of the inclined plane. Cannot take 1 or 3. Because the motion F dot SF is in the motion, in the direction of the motion. So that's why S you measure here, use Pythagoras theorem. So 1 square root of 1 squared plus 3 squared. So you get cert 10. So you substitute cert 10 here. Okay, so you get the answer. Another one, the cos theta here can use Pythagoras theorem. Okay, mu mg cos theta, right? So cos theta use Pythagoras, trigonometric ratio. Trigonometric ratio. So catua. So you use cos theta. 3 per cert 10. 3 per cert 10. So you get 29.4. Okay, so you round it off, you get 29 joule. Okay, so I didn't round this off. You with your answer you must round it off, because all the data given is in two significant figures. Okay, so now we go to the next question, the network done on the body. So the network done on the body, we use net force here. Net force. So net force along the inclined plane will be mu r, and we have mg sin theta. So mg sin theta will be positive because motion is downward. So mg sin theta will be positive. Refer to the direction of motion. That's why mg sin theta is positive and mu mg cos theta is negative. Okay, then distance is 10. So you substitute all the values, and sin theta we use trigonometric ratio. Okay, trigonometric ratio. So you get sin theta equals to 1 per cert 10 and cos theta is 3 per cert 10. Okay, so you solve this, network done is 19.6 joule. Okay, so this is 19.6 joule, the network done on the body. Okay, done for question 2. And lastly, question 3, the velocity of the body when it reaches the bottom, okay, is different from the question A because question A without friction, but question 3 is B3 is with friction. So let's compare the answer. We calculate the answer first using the same method. Okay, gain in kinetic energy equals to net work done. So gain in kinetic energy is half mv squared. So the net work done this time is 19.6 joule. Because got friction. We calculate just now network. The network we have to from the mg sin theta minus friction. Okay, so now we solve, we get V 2.80 meter per second. And this value, okay, compare with the 4.43, it's logic. If we think the logic, it less than 4.43 because of friction. Okay. Okay, sometimes the question might ask you to give reason why your answer is as calculated. Okay, so now we go to question 11. Okay, question 11. So a block of mass M here on a smooth plane, so that's mean no friction, inclined at angle theta, and the M here, this is M capital letter. So that's mean the direction of motion given here move up. So that's mean this M is larger mass. So pull up. So down, M here we're going down and M here moving up. Okay, so we are going to find this A value. Okay, this A value. Okay, so we choose the X, the motion is along the inclined plane as X axis. This is the Cartesian plane. So tension in the string, okay, these two is the same tension for the two, the string they share the same string. So here tension upward, here tension also upward. Action reaction force by two of them. Okay, so mg, and we resolve the component of mg here into mg sin theta and mg cos theta. Okay, next, this one M here, force is downward, mg as a weight, downward, another force is weight. Okay, so now we separate the body, separate the body. For these two, t minus mg sin theta, follow the right direction of A as positive. So t is positive minus mg sin theta equals to ma. Okay, so this is first equation. So for the second body with mass capital letter M, so is T, is mg minus T because follow direction of A as a positive. So mg minus T equals to ma. So this is equation 2. Okay, now we use simultaneous equation to find A. So we don't want T, so we can use simultaneous equation by equation 1 plus equation 2. So we plus this, we cancel t, and we get mg minus mg sin theta equals to ma plus capital letter ma. So factor out a, bracket will be m plus m capital letter. So bring m down. So we get a as the given here. Okay, and the answer is a. So this question, the answer is a. So hopefully you can understand. Okay. Okay, now we go to the final question. Okay, last question, Cikgu Non. Okay, so the two blocks are attached to each other by a massless string that is wrapped around a frictionless pulley. When the bottom 4 kilogram block is pulled to the left by the constant force P, the top 2 kg block slides across it to the right. So find the magnitude of the force necessary to move the blocks at constant speed. So assume that the coefficient of kinetic friction between all surfaces is 0.40. Okay, so 2 kilogram is the top block. Okay, M2, 4 kilogram is the bottom block. So we are going to find force, this force P. Okay, pulling force, and the mu is given all the same, is 0.40. So the mu friction, coefficient of kinetic friction is, there are two surface, the two blocks here, and the block 4 kilogram with the floor, with the floor. Okay, so the motion will be for the green block here. So 2 kilogram block, the motion will be here, but constant speed. So that's mean A is 0. Okay, and the motion is here because the pulling force is this way, and the 4 kilogram will move this way. Okay, so A is 0. Okay, so now we use the separate or body diagram method. We determine all the forces first. We have tension in the string and friction on the between the two blocks here as friction 1. Okay, and 4 kilogram, and the surface floor here is FR2. Okay, and tension will be this way, because the pulling force is this way. So tension in the string for 4 kilogram with the string attached to the 4 kilogram will be this way. Okay, so now for the top block, so this is the forces. So we use F equals to ma, Newton's law. So A direction this way, so T will be positive minus friction 1, so equals to M1A. But A is 0, right? So you can substitute 0 here, and we get F equals to mu R. So let's say the R, we name this as R1. Okay, so R1 is the reaction by the block 4 kilogram. Okay, so R1. Okay, so you substitute R equals to M1G, because R1 is equals to M1G, weight of the block, green block here, 2 kilogram block. Because the block doesn't fall and doesn't fly, so that's mean R1 equals to M1G. Okay, so substitute all the values and we get tension in the string equals to 7.848 Newton. Okay, I put here at 4 significant figures because we are going to substitute this into the next one. Then only you round it off to 2 significant figures. Okay, so for the second body, which is 4 kilogram, so we have P forces, or we have P, T, friction 2. Don't forget friction 1 because the 4 kg also has the 2 kg block on top of it. So that's mean friction 1 also take into account for the total forces here. Okay, forces act on the 4 kilogram. So don't forget FR1. But FR1 will be opposite direction because the P is pulling to the left. To the left. Okay, correct. To the left. So that's mean friction by the top block here on this one, on the 4 kg will be to the left. Okay. So be careful with the friction one. Okay, so now we determine all the forces that act on the 4 kilogram block. So this is where the common mistake student makes. Forgot about this friction one. So we have two friction here. Friction R2 for the surface floor and FR1 for surface between the two blocks. Okay, so now use Newton's law, F equals to ma. So the resultant force will be, P will be positive because it's in the direction of A. So P minus T minus FR1 and minus FR2. So equals to M2A, but M2A is 0. Okay, because constant speed. So 0, and you the mu FR2 is mu R2, okay, and R2 is equals to M. So the M here, be careful. M here is M1 plus M2, the both block. Okay, so because there is a block on top of the 4 kg, so that's mean R2 is because of the reaction force by the weight of the two blocks. So M1 plus M2. Okay, this one also be careful. Many students make mistake here. Okay, mu R1 we calculated just now on top here. Mu M1G. Okay, so now it's time to substitute all the values. So M1 plus M2 here is 4 plus 2, 4 kg plus 2 kg. So mu is 0.40, G 9.81. So mu M1G is 7.840, calculated already on top. So we just substitute, and T also we substitute into here. And we get the final answer. P is 39.2 Newton. So that's the answer. So I hope I'm not too fast, explaining too fast because of the technical problem just now, but it's okay. You can keep on continue watching the video later. Okay, so I give the uh, to our moderator, Cikgu Nun.
Okay, thank you so much, Madam Rosmaya. So, Alhamdulillah, we have reached the end of today's lesson, the real end of today's lesson. Congratulations to those who are able to follow our lesson from the beginning till the end. So, before we end our session for today, I will announce the last two-digit code for the credit claim. So, the last two-digit code is 76. Okay, 76. So, all of you, please stop posting your comment for a while and click the subscribe button and activate the icon bell so that you will not miss the next class lesson. Then, if you find the lesson was beneficial, click the like and share to your friends on your social media. Spread and share the goodness. Once complete, type down on the chat box, and the certificate link and also the credit claim link have been given in the chat box. Okay, so please take note that the link will end half an hour after this live. Make sure that to use the EDD email or MOE email only to log in. So incorrect email use will not be entertained, and you have even if you haven't got one, please apply. Okay, so the link to apply also given in the chat box. And if you wish to get more information on the online classes, so you can go to the www.academyyoutuber.com, and those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all students for joining today's class. You are really awesome. Feel free to share this free tuition class to your friends and teachers all over Malaysia. So this is a collective effort from all teachers throughout Malaysia for all the students throughout the country. Thank you for being a YouTuber Academy supporter too. So I think that's it for now. See you in another lesson. Remember the hashtag bermula percuma, selamanya percuma. So Assalamualaikum warahmatullahi taala wabarakatuh. Stay safe. They will meet again. Next week is holiday. So another 2 weeks. So
Yeah.
same time. Okay. Bye.
Don't know yet.
I don't know yet when.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.